Okay, in this video, we will continue to work on problems in Lab 4. Before watching this video, make sure you have already tried those problems by yourself. Let's look at question 3. Download the data file. So it is a zip file. So if you download it, you will get something like this one. In this zip file, it contains data files and codebook for National Health and Nutrition Examination Survey, where the file end with F are for 2009 to 2010, and the ones end with G are for 2011 to 2012. Yeah, you can see those are end with F, those end with G, right? We have F and G. The files with extension XPT, they are called the SAS export files, so which are used to save data to be used across computer system. The data file can be directly manipulated by SAS. For example, so here I just give you an example to use those XPT file. Suppose you want to use data from this file. First, you need to use a lab name, right? So you just create a alias to this file. So make sure to write this XPOT, right? XPORT. Yeah. So write this keyword tells us. So this is a export file. So then for this one, so essentially I just copy the file in here. Oh, by the way, so if you want to use here, see, first you need to use this one, this lab name dot. So after that, so this one just will be the name of this file. Okay, so this is how to use it. Yeah, so then by this way, I essentially just copy the data to work library. Yeah, so then I run this one to check the contents of this file. So the first question is, so how many observations and variables in each SAS export file? The number of observations and variables are summarized in the following table. Yeah, so you load the data and compare the number of observations and variables. So to make sure you load the data correctly. So let's try to do that. So I copy this one. Of course, for those files, and you need to upload to your online cloud storage. Yeah, so like here, so I load everything here, right? So then in this library, okay. Yeah, so then I specify the location of the file. Yeah, so make sure then I run it. You can see, so we have 10,537. So that's number of observations. We have 43 variables. Yeah, so this is a list of variables. Okay. So then let's just try to load every data set. So in total, we have 6 of them. Okay. Yeah. Essentially, you just copy paste this one. So we have demo. Okay. So then we have the demo for the next one. So this one end with G, right? So that's 2011. Yeah, so we have G, okay, and 11. So this will end with G. This will be G and G. 9,700. So 7,037 variables. That's good. Next one, next two, okay. Instead of demo, so we have a BMX. So then we have, not here. We have BMX, and BMX. So let's run it. 10,000 and 253. Yeah, so this one is correct. So then for the next one, we will replace this one by BMX, 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 and the BMX. Okay, so run this one. 9,338. Yeah, so this is correct. So then BPX. BMX becomes a BPX. BPX, 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 and BPX, BPX. Okay, so run this one. 10,253. Yes, so this one is okay. Then BPX, 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 and BPX. Okay, so the last one, 9,338. Okay, so that's fine. We load all the data together. We load all the data. Then B, so create a new dataset only containing variables SEQN and MBX, BMI. So it means the body mass index. Yeah, so from these two datasets. Define a new variable year, so which equals a character string. This one for if observations from the first dataset, and so this one for observation from the second dataset. Yeah, so to make sure to remove all observations with missing value and how many observations in this dataset. So let's first work with the first one. I think we don't need to work. Yeah, I think we can work from them together. Yeah, so just assume the new dataset I want to create is called data BMI, right? Essentially, see, because these variables appears in both data, right? Yeah, so we just want to combine them row by row. I mean, just one set on top of the other. So this is called concatenation. For concatenation, so we use set body, right? Okay, not body, from the BMX. Yeah, I think so. We call that BMX 2009. So it is from this set, right? So BMX. Then we have BMX 2011. We want to set them. Yeah, and so we only want to keep two variables, right? So we want these two variables. Yeah, so I just copy those names here. Yeah, so we only want to keep these two variables. And we only want to keep missing values. I remove observations with missing values, right? So this just means if not missing, right? So BMX, BMI. So this variable is not missing. The next thing is, yeah, so we will have a variable year, right? Yeah, so this will equals different string according to which observation it comes from. Do you still remember? So we may have, so for this, we may have a temporary variable in, right? So this can tell us from which variable from which data set so that variable comes from. In, I think so here we can have the use in BMX 2009. Yeah, so then we have in equals in BMX 2011. Okay, so according to this in variable, so if in BMX 2009, then we will have year equals this string, this character string, right? Similarly, so if in BMX 2011, then year equals 2011 to 2012. Yeah, so because this data set is too large, right? So then maybe we just check the contents to check it, BMI. So let's run this one. So yeah, this is question 3B, right? Okay, so let's run this one. You check the log. Well, seems everything is fine. So then we have two variables, right? So BMX, BMI, and SEQN. Okay, and also this is number of observations. So we can check here, compare with here. We have the result should have. So this is total number of observations, right? Yeah, so looks fine. Well, so how many? So those are the number of observations from each data set. Yeah, so then we can use a proc flag to check that. Proc flag, so data equals BMI. So table, we have that for year, right? Okay, why there's no table for year? BMI table year. Keep. Oh, so see, keep. So I only keep these two variables. I should also keep the variable year, right? So should have three variables. Yeah. So then this will be fine. See, we have three variables. So this is a frequency table for year. See, this is a number of observations from the data ending with F. Yeah, so 9,400. Yeah, so 9,412. So this is 8,602. So this comes from the second data set. Yeah, so this one is fine. Question 3. So is this variable unique for each observations in the above dataset? Please check it. SEQN. Yeah, because for here we just combine two datasets together, right? So this SEQN supposed to be unique. Yeah, but we just want to make sure. So whether it is unique. If they are not unique, so just means we have subject appears in basically in these two different years. So the technique we will use is we will just try to get a frequency table for that BMI, basically for that variable. Yeah, so table SEQN, right? Yeah, so then I will output that one to BMI table. Just outsource that frequency table to a dataset. Because the data is long, I do not want SAS to show the output. Okay, so then I use proc flag again. Just this one we show the frequency table of that table. We just want to know so whether those count, right? So if the count is always 1, so then the observations are unique. Yeah, so let me run this one. See, the count is 1, so it is unique. Well, so then this data, so this data is unique. Okay. Not the data is unique. I mean, for the value for this SEQN, so this value for this variable is unique. D. create a new data set contains two variables. Okay, so from these two data set, and so define new variable year. Looks similar, right? Yeah, but I just ask you to do that for a different variable. So called this RIDAGEYR. Well, so then for simplicity, so I just copy that. I just copy this piece of code. So then I just do modify it slightly, and so then we should get the information. Yeah, so let me call this guy age, and so then the variable comes from demo. Yeah, so demo, I think see, I call it demo, right? Yeah, so demo. Change this to demo. In demo, and in demo. This variable is not this one. This variable should be this age. Okay, should be this one. Then the result will be age and age. Okay, so let me run this one. In total, yeah, so see, we have 20,293. So it is this one, right? So for the frequency, from the first one, we have 10,500. See, 10,537. The next one, we have 9,756. Yeah, so those are the data. So this is for D. Then we want to E. Merge the above two datasets by SEQN. So how many of the observations do not have a value for BMI? So then we will merge the data by some variables. Then of course, so first we need to make sure the data are sorted by that variable. So then we will use proc sort data. The first one is the BMI, right? So sort the data by SEQN. Then we sort the data, the second data age by SEQN. So then we create a data, so age, BMI, right? So we want to merge these two data sets by age and BMI. So merge these two data sets by SEQN, right? Yeah. Because I want to ask you, see, when you merge that, so you need to, because we want to know, so which observation comes from which data set. Because here, see, because eventually I want to ask you how many observations do not have this value. Oh, I think this is fine. Yeah, I think we need to be aware. So for these two data sets, so each of them have three variables, right? Yeah, so in the BMI, so it has that SEQN, and also has year, and also has that body mass index. And so for age, for this data set, so it has variable SEQN and also has a year, right? Yeah, because we have year in both data sets, so when we combine it to get confusion, so we need to rename, right? So for that year, this year I call it year in age, and rename, right? So for this year I call it year in BMI, right? Yeah, so then by this way I will merge them together. Okay. Let me run this one. Does it work? looks fine. So there are this number of observations read from the first data set, number of observations read from the second data set, right? So this is the total observations. Yeah, so we have 20,293. Yeah, so this is the total of them. How many of the observations do not have a value for BMI, right? Yeah, so how to do that? I think we can use proc means data age BMI. So the variable BMI, right? So we want n miss. N miss is the number of missing. Okay, so let me show that. Why that's that's a variable is called is not called BMI, so it is called BMX BMI. Yes, called BMX BMI. Yeah, so 2,279. Yeah, so that's the number of subject. So without BMI. Update dataset to write only 3 variables in the merge data to a CSV file. Or use data step, because we know how to write the data using proc export, right? Yeah, but now I want you to use data step to write this to a Excel file. If you want to do that, so then you need to use a data none. Yeah, because we do not want to create a new data set, we just want to write the information. Set age BMI. We will have a file, so this will be the CSV file we want to write. So age BMI.csv. DLM delimiter, right? So tells us we want to use comma to separate the values. And if n is 1, so for the first row, so then you need to put the name of the variable seqn, comma age, comma BMI, right? So then just put seqn. Then for age should be this one. This is the name for age. So then we have the BMI. Yeah. So then it should be fine. Run this code. Well, see, 20,294 records written to this file, and try to find this file in here, right? So you can download it, right? Yeah, so then you can open it. See, those are just the file we want. Okay. So this is question 3. Yeah, so you can check the code. Check the code if you want. Yeah, so check the code again. The code. This is answer for D. And also for the last question. Okay. Next one, question 4. Download the following data file. So let's check that. This is data file. So we have some students, right? And so we have grades. Okay. So load the data into SAS and then transpose the data. Maybe let's load the data first. Well, so the values, so things are separated by space. So we can just use, let's just load it. Yeah, so file name, grade, URL. So then write the name, the location of this one. Okay. data grade let me just call it grade 3, yeah, because the name is called stat grade 3, right? Grade 3 in file, so we just go read from this file, because the first row, maybe I copy this to here. Yeah, because the first row is a name, right? So we want to read data from the second row. So the first OBS will be 2. So then input, so I just write the name of the variable. The first one is name. So then we have gender. $sign is needed because so they are character variables. So then we have stat 7000. So those are numerical, right? So stat 7010 and stat 7030. Okay. Proc print data equals grade 3 and run. Oh. Run. Hey, what's wrong? Why the data does not exist? Oh, grade 3. Okay. Let's run. Yeah, so looks like the data are loaded correctly. Now, so we want to transpose the data, right? So the resulting transpose data contains 4 variables, so name, gender, class, and score. Notice that in original dataset, one observations contains scores for 3 courses, and well, in the transposed data, so one observations contains only 1 course. This is called a wide data, right? So we discussed proc transpose to do that before. Okay, and so now, so I just ask you to do this in different way, right? Yeah, so see, first use transpose, then use data step with multiple output statement. So if you want to use proc transpose data is grade 3, right? So then you need to specify the output data. So I call it out grade 3 8 grade. Okay, grade 3 8. So then we want to transpose the stat 7000, stat 7010, and stat 7030. So transpose these 3 variables and by name and gender. Yeah, since you have by, right? So then here you need to sort the data by name and gender first. So the data equals grade 3 by name and gender. Then we will display the sorted data. Proc print data is grade 3A. Yeah, so let's run it. See, looks like the data are sorted, but we need to change the name and also the name for this one. Yeah, so to change the name for here, so we need to use option name. Yeah, so option name after this one, so name should be the class, and for that column 1, for this column 1, we also want to change that to score. Then here we will use the rename equals column 1 to be score. Yeah, so let's run it again. Okay. Yeah, so looks like it works. If you want to use a data step, so how to do that? Yeah, so if you look at the data, so this is data. Essentially, so this is just means we read 1 observation, but we write this as 3 rows, right? So see, 1 for 7000, 1 for 7010, and 1 for 7030. Yeah, so we will use a data step, and the output data, let's call it grade 3B. Okay. Yeah, so we will start from the original data is data 3, right? So we want to output. Yeah, so basically for first one, the class will be 7,000, right? Yeah, and so the score will be the score of 7,000. So then we output this. And so similarly, we have class equal to the second class, 7010. Oh, I missed a zero, comma. So then we will have score equals the score of 7010 output. Yeah, so then class equals to the last class, 7030. And so the score will be stat 7030 and output. Let's print the grade 3B and run to see so whether it works or not. Well, so seems it is what we want, right? Yeah, but for these three variables, of course, so then we do not need these three variables anymore. Yeah, so then we will drop them. We will drop stat 7000, stat 7010, and stat 7030. Yeah. So after you drop these three variables, right? Yeah. So let's run both code together, and so you expect to find the same result, right? The same result. Yeah. So this just helps you understand how to use multiple output statement in a data step. Let's look at this one. Download the following data. So this is the data. It's just the name, gender, department of some students, and also exam 1 and scores for exam 1 and exam 2. Yeah, so let's load the data first. We will have a file name, my CSV, okay, CSV URL. Yeah, so we add this one. Proc import, so data is not data. The out is the grades. The data file, yeah, so data file should be the my CSV, the DBMS, the format is CSV, and so we have replaced. And then we proc print data is grades. Yeah, so run it. And the data are loaded correctly. Okay. So now the instructor wants to scale the actual exam scores by dividing the original score by the maximum score. So note that you are not allowed to type the value of the maximum score in your SAS code. Scaled code so will be the original score divided by maximum. So when we and then multiply by 100, right? Yeah. So essentially, so the highest score so will be scaled to 100. When I say you are not allowed to type the maximum score in your SAS code, so what I mean is, see this maximum, right? If you check the output, so exam 1, so seems the maximum maybe will be 95, right? Yeah, so then you cannot write a code and to say something like grades updated, right? Yeah, so then you can set grades exam 1 new, for example. Yeah, so this will be new grades, right? Exam 1, so divided by maximum, right? Times 100. Yeah, so because this is maximum is 95, so you cannot type 95 in this way. Okay. Yeah, so you need to use code to do that. How can we do it? So here I give you a hint. This is one way, right? Maybe you can have other way to do it. Yeah, but this is one way. So just calculate the maximum, then merge this value to the original data. So how to calculate maximum? So we can use the proc means, right? Yeah, so the data grades. So first you need to calculate that value, exam1, right? So you output out equal to grades maximum, because we want the maximum of exam1. So here we can directly say maximum equal to exam1 max. Yeah, because there's no need to use a parenthesis to say exam1. Yeah, because so here, see, you list the variable, right? So there is only one variable, so there is no, SAS will not get confused. Yeah, so we just say maximum, so then it will be the maximum of that. Run this one. See, maximum 95. So if you check proc print data is exam1 max, you can see why it says it does not exist. The data is called grades max, right? Yeah, so it's called grades max. Well, see, exam1 max, right? So this is the maximum value. So now I want to merge these to the original data. Yeah. By merge, right? So seems usually so we need to specify how the value are can be merged. Yeah, and so then, but there's no index for those, right? So then we can manually create one. Yeah, so then because one row in the grid max will be merged. This value will be merged to every row, right? So then I will create a data grades. Okay, so then I will set ID is 1. So this is just, not set, set grades. So then I just define ID equals 1. So I just manually create a variable, so the value of this variable is constant. And see, let's check grades. So then I just add a constant variable to the data set. You can see I have ID 1, right? So they are 1. And for that max, I also do something similar. Yeah, so the grades max. Okay, so start from this grades max. I create one called ID. Yeah, so then you can print data. So we can check the resulting data set. Yeah, so it has ID 1, right? See, if you now I run both together, you will see now for both variables, I have a variable called ID, right? Yeah, so basically, if I will merge these two data sets by ID, so this row in the second data set will be merged, will be added to every row in the first data set. Yeah, so then I will say set grades and set grades max. For here, I only want to keep two variables, ID and exam1 max. Okay. So, not set, sorry, I will say merge. Yeah, because I want to merge them together. Of course, so it is by ID, right? So then the exam1, so this exam updated scaled scores, right? So will be value of exam1 divided by exam1 max, then times 100. We do not ID, right? Do not need to keep this variable, so I drop it. Well, so then proc print data grades updated. Okay, yeah, so let's run this one to see. You can see, so I have exam 1 max, so this is included in every row, so they are the same value, right? So I use exam 1 divided by this value times 100, so I got the updated score. Yeah, so this will be the updated score. Okay. Yeah, so this is just for the question 8, right? Yeah, so this is for part A, I think. So start from here. Question 8, right? Yeah, so start from here to here. Well, so then we will have a question B. So what is question B? Use data step to calculate the sample size, mean, standard deviation, compare your result with the prog means. Of course, so we can use prog means to calculate sample size, mean, and standard deviation, right? See, for example, standard deviation of exam 1. Yeah, so then we can say prog means data is grades, right? Yeah, so we just want to, the var will be exam 1. If you run this one, see, SAS can calculate the n, the mean, and also standard deviation. Yeah, but so here I ask you to use the data step to do that. Yeah, just want to train you basically to see so how to get those values. Yeah, so just train you to think, to train your skills of programming. So those are the formulas, right? See, for the average, right? So it will be computed as just you do the summation, then divided by n. So notice we have something accumulating total, right? Yeah, so see if you can first calculate the sum and then divide it by n, right? So then you will get that total. For this one, means see, for each of the value, you minus mean, right? Calculate the squared sum, divided by that constant, take square root, so you will get the standard deviation. So basically, we need to do those calculation for each row. I will say yes for each row. Okay. Data grades more. I want to set grades, right? If we want to get the sum of this one, essentially we just want to do a cumulative sum, right? So I just calculate exam 1 sum plus exam 1, right? See, for example, so if you run this one, maybe print data is grades more, right? Yeah, so if you run this one, see, in the last column, so that's the cumulative sum. So sum of those exam 1, then divided by n, right? Yeah, so then I will say the mean, exam 1 mean, right? So will be the sum, exam 1 sum divided by n. So what is n? In fact, n equals underscore n, right? See, this just tells you so which observation you are currently working. Yeah, so then this will be the n. Maybe I output the first part together. See, the mean will be 80. You can see, so 80.9091. Yeah, so the same value of mean, right? Then we want to get that for standard deviation. For standard deviation, you can see you will get this formula will be better, right? See, you first calculate the cumulative sum of the squared x, right? Yeah, so then you just 1 x2, right? So you just use the this S square SEQ. Yeah, so you use the sum statement. So we just do the exam1 times exam1. Okay, so let's try that. Yeah, see, we have the sum of squared terms. For each one, we will minus n times this guy divided by n minus 1. Yeah, so then we will do like exam1 standard deviation just will be the square root of exam1 square, right? So minus n times the mean, exam1 mean times exam1 mean, right? So this one divided by n minus 1. See, this is 7.9. Oh, let's run this part together, run proc means together. 7.98, 7.98, right? Yeah, so the same value. It's good, right? Yeah, in fact, so for those results, in fact, we only want to keep the last row, right? So we only want to keep the last row. So then we can write the last row to a new data set. Well, so here I just want to generate two data sets together. Yeah, so one called this one, the other one called stat, right? So if, so how to tell, so if it is the last one. So here we will have a AND option, not AND option, AND equals the last one. Yeah, so then this SAS will create a temporary variable called last one. So the value is 1 if it is the last row of the dataset. Yeah, so if last one, then output grades stat. Yeah, so then I want to print data is grades stat. Grades stat. And I move this one to here. So let's run those. Okay. That's something wrong. Stopped. Set. Oh, I think so. That's, we shouldn't write these parentheses. Yeah, if you write parentheses, so SAS will interpret this as an option to the dataset. So this AND is essentially an option of that set statement. We will run this one. Looks fine, right? See, this one is the standard deviation, and so this is a mean, this is a mean. Yeah, so notice, so in this data set, we only want to keep 2 of them, right? Yeah, so then here I just tell SAS I only want to keep n exam1 mean and exam1 std. So then run this again. See, n is 22, right? Yeah, so the mean will be this mean, standard deviation is this standard deviation. Notice, so where is the grades? I mean the grades more. Where is this dataset? So seems there's no this dataset, right? Yeah, because before we set output to grade stat, right? By default, so SAS will write the output to grades more. Yeah, because you have this one, so now you need to explicitly tell SAS you want to write data to this grades more. Yeah. And then you write. See, first this is the data grades more. This is the data grade stat. So this is the output of proc means. Okay. Of course, for this one, essentially, so there is no need to calculate the mean and standard deviation in this way. Yeah, so I ask you to do that. Just want to train your programming skills. Yeah, just try to understand so this sum statement, right? So and also this how to generate multiple data set together. Okay, last question. Yeah, maybe you want to check the code, right? So this is code. Check the code. Okay. Last question. Download the data. I think so. This is the same data, grades, right? So then I just copy those to here. Yeah. So I have load the same data. Create a subset that contains students with highest exam 1 score in his or her department. I think so we mentioned this in class. Easiest way is to use the if, use that first dot variable. Yeah, use that automatic variable. So we first sort data, grades, and by department. So now we want to do in descending order of exam 1. So then the data, new data, I call it best one, right? So I set grades, okay? If first dot department, right? So then I keep it, yeah. So otherwise I will drop it. So for department descending exam 1, for print, this is best one and run. Okay. Let's run this one. You can see, so we just have the best score for each student. Yeah, so in each department. Then just do some similar things for the highest exam 2 score. But notice it says, notice that 2 students have the same highest exam 2 score in forestry. Maybe we can check that first. Ideally, we may want to do something similar, right? Yeah, so best two. So now we want to do that for exam 2. Right, and exam 2. So if you run it, exam 2 for forestry, so this is 99, right? Yeah, but if you check the whole data, forestry, if you check those, it has 99 and 99. So 2 students have the same highest score. Well, so if this happens, so there is one potential error of this method. Yeah, because so if there are more than one value have both of them they are highest, right? So in this approach, so SAS just only pick the first one. SAS will only pick the first one. So this is a potential error. See, this is sometimes it's tricky in programming, right? See, because for this one, if you use this approach, so definitely the log window will not show any error. Yeah, and so this logic so works for some scenario. Yeah, but however, just for some other scenario, it does not work. Well, so then for this one, so how can we solve it? Well, again, of course, so there are maybe a possible way, right? A different way. Here, I just want to mention one possible way. So we can calculate the maximum for each department, right? So then we just pick student, so whose score equals to that maximum. So if there's only one student equal to that maximum, so then we only pick one student, right? So if there are more than one student, so whose score equals to that maximum, so then we will be able to pick multiple students. Yeah, so this is the strategy. let's first use proc means. So then we can calculate the maximum exam 2, right? I want to output, so out equals grades 2, the maximum will be exam 2 max. For print data equals grades maximum, and run. Oh, so this should be computed, so by department, right? Yeah, because by department. Yeah, because so we want a maximum for each department. Yeah, so if you run it in the last one, you can see, so that's the department and the maximum, right? So maximum for each department. So then I want to merge this data set to the original data set, right? So data best 2. Okay, so then I want to merge grades. So that's the original data set to this grades max. Yeah, so in this grades max, so I only want to keep variable department and exam 2 max. Okay, of course, so by department. Yeah, so we will print data equal best 2 and run. Yeah, so if you run this one, you can see we will have one extra column, right? So those are just the maximum for each department. You can see for those forestry, right? Yeah, so they have the same maximum, right? For students from math department, they have the same maximum. So then we only keep observations, so whose exam 2 equals the maximum. Yeah, so then we will pick those if exam 2 equals exam 2 max. Yeah, so then run this one. You can see we have 5 observations in total. Yeah, and for forestry, so we have 2 students, so they have the same maximum. Okay. Next, so concatenate the above 2 datasets together, remove a duplicate observations if any. Yeah, so this is question C, right? To concatenate, I think we just data both. Yeah, so both will be name of the new data set. So then we just set best 1, set best 2. Okay. So then print data both. We run it. Oh, exam 2. So this should be dropped. This should be dropped. We want to drop exam 2 max, yeah, from the best 2. Okay. Yeah, so then you concatenate them together. Well, you may notice, so see, Roger and Roger, right? And Grant. So clearly, so they are overlap. So we want to remove duplicate. There are more than one way to do it, right? Yeah, but one easiest way is to use a proc sort data is both. You just say no dup recs, so records, right? Yeah, so then by name and gender. Yeah, so first concatenate, then remove duplicate. Yeah, and so then print. Yeah, so run that. See, we have 7 students in total, right? So the duplicate has been dropped. Find students whose both exam scores are the highest in his or her department. So the first dataset, best 1, so they are the students with best exam 1 score. The second dataset, best 2, so they are students with the highest exam 2 score. So basically, we just want to find students, so appears in both data set, right? So we will have, so this is question D. Okay, so first we sort them by name, best two by name, right? So then we just create data. The result data, I call it common. So I want to merge them, best one and best two. By name, right? Cause I only want to work with name, right? So in here I only keep name, okay? Yeah, and so for the first one, I will have a temporary variable in, right? For example, so this is in best one. Yeah, so let me put it in second row. So then we have a in temporary variable for in best two. See, if this value is 1, just means the data comes from the row, I mean the name comes from this guy, right? So if this value is 1, means name also comes from this observation. So if we want observation comes from both, right? So then in best 1 and in best 2. So both of them should be 1. Yeah, so then print data equal to common. You run it. So this just shows the name in common, right? Yeah, so then we find students in common. Next one, find students whose exam scores are the highest for only one exam, but not both. Yeah, just means either or, okay? I think so we just needed to modify this code slightly. Data already been sorted, and there's no need to sort the data. So the name of data set, I call it only one. Okay, only one, and display only one. Only one. Okay. Yeah. So now, see, the value is either 1 or 0, right? So when the first is 1, the second should be 0. Or when the first is 0, second should be 1. Yeah, so basically we only want to keep observations such that so their value are not equal, right? Yeah, so if 1 is 0 and the other is, 1 is 1, one of them is 1, the other should be 0. Or so this is 0, the other is 1, right? So the value should be different. Yeah, so by this one, we will have, see, this is the students, so they have highest score in only one exam, but not both. Last question. Instructor made errors in grading. Yeah, so Alice scores for exam 1 should be 85, and Hank's score for exam 2 should be 88. Yeah, so please update the original dataset. So we just create a dataset for those correct scores. Yeah, so this is question F, right? Question F. And this is E. Okay. Data correction. Yeah, so input name. We have exam 1 and exam 2, right? Data lines. So then we have Alice. So we know exam 1 should be 85. 85. No change for exam 2. Yeah, so I just write missing. For second one, so Hank, exam 1 will be missing, right? So exam 2, so should be 88. Okay, so then what we want to do is we want to basically update the original data, right? So we say grades. We will use modify grades and correction. Okay, so by name. So we just use name just to match rows, right? Yeah, so then print data is grades. To make sure it do the job, so then I will basically print the data before that and after this modification. See, first one we can check Alice. Alice, see, original score is 77. So now Alice, where is Alice? So now it's 85, right? So we have Hank, yeah, so 76 for the second exam. So Hank, yeah, so now it is 88, right? Yeah, so the score has been updated. If you check the log window, you will see this one, right? See, the data set grades has been updated. Yeah, so there were 2 observations overwritten, 0 observation deleted. Okay, right? Yeah, so means the values are we update the value correctly. Yeah, so this is an example of statement modify. Yeah, so you can check the code if you want. Yeah, so those are the solution. Okay. Yeah, so we discussed all problems.